So we have here two syringes that has had some heat exposure. You can tell by looking at each one of the bags, you can see it is blown up. So what we're going to do is to show you what that looks like on the inside as well. So we're going to open that syringe, or open the bag for the syringe. Now, you'll be able to tell the difference here. Usually, if you have a syringe that is acting normally, the gel is going to come out and it's going to be thick and viscous, so it should be able to attach easily to the enamel. But you can see the difference here. As you can see how liquidy that is. That's a result of heat exposure. It is expanding inside the syringe body and it's converting over to water. Okay, so we're going to show what the gel should look like as it comes out from the refrigerator where it should be stored. On the back of that syringe, you'll be able to see the temperature range that it should be in.
Yes, right here.
And it labels between 2 and 8 degrees Celsius. So as we showed before, the syringe, after having some heat exposure, the gel comes out very runny and liquidy. So we're going to show the difference here from a properly stored syringe. Okay, that's the viscosity we're looking for. It should be thick, viscous. It should be very easy to attach to the enamel, as you can see. Okay, so the syringe to the left, you can see, is very well vacuum sealed. And it's vacuum sealed because we want to be able to see that it is in perfect condition. As you look to the syringe and the packaging to the right, you can see there's been some heat exposure because the gel inside from the heat exposure has expanded. So as it expands, it converts to gas, and that's what's filling out that foil and making it look like a balloon. And you can see the results on the actual glass here. To the right, you can see it looks more liquidy, more runny. And to the left, that's the way the gel should look. And that's reflected in what you see there.